Welcome to our deep dive into the reality of water resistance in smartphones. Today, we'll unravel the engineering marvels behind modern devices and expose the myths and truths about their ability to survive water exposure. From the science of waterproofing to the marketing behind IP ratings, we'll explore how brands like Apple and Samsung design phones to withstand splashes, spills, and even submersion. We'll also look at why no phone is truly waterproof and what the future holds for mobile technology. Let's begin our journey into the hidden world of smartphone water resistance. Smartphones are our constant companions, exposed to rain, spills, pools, and even accidental drops in the sink. Water resistance isn't just a luxury, it's a necessity for modern life. But what does it really mean for a phone to be water resistant? Is it safe to take your device swimming, or is it only protected against brief splashes? Understanding the difference between marketing claims and engineering realities is crucial for users. In this scene, we'll set the stage for what water resistance actually means and why it's a key feature for today's devices. Creating a water-resistant smartphone is a feat of engineering. Designers must balance sleek aesthetics with robust protection, ensuring every port, button, and seam is shielded from moisture. Unlike rugged devices, mainstream phones aim for elegance without sacrificing durability. Engineers use a combination of seals, gaskets, adhesives, and coatings to keep water out, all while maintaining usability and repairability. This scene introduces the core engineering challenges and solutions that make water resistance possible in today's smartphone. Waterproof seals are the unsung heroes of smartphone protection. These tiny barriers are placed around critical entry points, like the screen, buttons, and ports, to prevent water from seeping inside. Made from specialized materials, seals must withstand repeated use, temperature changes, and physical stress. Over time, they can degrade, which is why water resistance isn't permanent. In this scene, we'll explore how seals are engineered and tested, and why their effectiveness is central to a phone's survival. Adhesive layers are another crucial component in water-resistant phones. These strong, flexible glues bond the screen and back cover to the frame, creating a tight seal against moisture. Unlike traditional screws, adhesives distribute pressure evenly and can absorb shocks, but they also make repairs more challenging. Engineers must carefully select adhesives that remain effective through heat cycles and physical impacts. Let's look at how these invisible barriers contribute to water resistance and the trade-offs they bring. Rubber gaskets are used around buttons, ports, and other openings to provide flexible, reliable protection. These gaskets compress when parts are assembled, forming a watertight barrier that can withstand repeated use. Over time, however, rubber can harden or crack, reducing effectiveness. Manufacturers must balance gasket thickness and softness to ensure lasting protection without compromising usability. In this scene, we'll see how rubber gaskets are designed and why they're vital for water resistance. Nanocoatings are a modern innovation in smartphone protection. These microscopic layers are applied to internal components, making them hydrophobic, meaning they repel water. Unlike physical seals, nanocoatings don't block water but prevent short circuits and corrosion if moisture gets inside. They're especially useful for protecting delicate electronics like microphones and sensors. We'll explore how nanocoatings work, their limitations, and why they're a key part of the water resistance puzzle. Pressure balancing is essential for phones exposed to changing environments. When a device is submerged or exposed to altitude changes, internal pressure can build up, risking leaks or damage. Engineers use pressure vents and membranes to equalize pressure without letting water in. These solutions are subtle but critical, especially for devices with high IP ratings. In this scene, we'll see how pressure balancing works and why it's important for real-world water resistance. Smartphone speakers need to deliver clear audio while staying protected from water. Engineers use special membranes, thin, water-resistant films, that cover speaker openings. These membranes allow sound waves to pass but block water, balancing performance and protection. Over time, membranes can degrade or tear, so their quality is crucial. We'll examine how speaker membranes are made, tested, and why they're a clever solution for water resistance. SIM trays are a common weak point in water-resistant phones. To protect this opening, manufacturers use rubber gaskets and tight-fitting trays, sometimes adding adhesive or nano coatings. Despite these measures, SIM trays can still let water in if not properly closed or if seals age. We'll explore how SIM tray sealing works, the risks involved, and why users should be careful when swapping SIM cards in water-resistant devices. USB ports and charging connectors are essential but risky for water resistance. Engineers use rubber seals, membranes, and sometimes nano coatings to protect these openings. Some rugged phones use flaps or covers, but mainstream devices rely on internal barriers. Over time, repeated plugging and unplugging can wear down protection. We'll look at how USB port protection is designed and why it's a balancing act between usability and safety. Even with external barriers, moisture can sometimes reach internal components. To prevent damage, manufacturers use corrosion-resistant materials and nano-coatings on circuit boards and connectors. These measures help phones survive brief water exposure, but prolonged contact or salt water can still cause irreversible harm. We'll see how internal corrosion resistance is engineered and why it's a last line of defense in water-resistant smartphones. Contrary to popular belief, most smartphones aren't completely sealed. Engineers design devices to survive water exposure without permanently sealing every component. This approach allows for repairs, heat dissipation, and usability. Instead, targeted seals and coatings protect critical areas, balancing protection with practicality. We'll discuss why full sealing is feasible and how selective engineering keeps phones safe without sacrificing function. IP ratings are the industry standard for measuring water and dust resistance. IP stands for ingress protection, and the numbers indicate how well a device withstands exposure. For example, IP67 means a phone can survive immersion in up to 1 meter of water for 30 minutes, while IP68 offers higher protection. We'll break down what these ratings mean, how they're tested, and why they matter for consumers. IP67 and IP68 are the most common ratings for smartphones. IP67 means protection against immersion in 1 meter of water for 30 minutes, while IP68 can vary, often up to 1.5 meters or more, sometimes for longer periods. However, these tests are done in controlled labs with fresh water, not real-world conditions. We'll compare the differences, limitations, and what users should know about these ratings. IP ratings are certified through rigorous laboratory testing. Devices are submerged in tanks of fresh water at specific depths and times, then checked for leaks and damage. The tests don't account for salt water, chlorine, hot water, or physical impacts. We'll explore how lab testing works, its limitations, and why real-world conditions can be much harsher than the lab. IP ratings specify depth and time limits, like 1 meter for 30 minutes. These limits are based on what the device can withstand without damage. Exceeding them increases risk, and even within limits, factors like water temperature and movement can affect results. We'll break down how depth and time are determined and what they mean for everyday use. Lab tests use fresh water, but real-world exposure often involves salt water, like oceans or sweat. Salt is highly corrosive and can damage seals, gaskets, and internal components. Even brief contact can cause lasting harm, and manufacturers warn against salt water exposure. We'll examine why salt water is so dangerous and how it affects water-resistant phones. Swimming pools contain chlorine, which can degrade rubber, adhesives, and coatings. Phones exposed to pool water may suffer from weakened seals and increased risk of leaks. Manufacturers recommend avoiding pool use, even for water-resistant devices. We'll look at how chlorine affects smartphone protection and why pool water is a hidden threat. Hot water can soften adhesives, expand rubber, and increase internal pressure, making leaks more likely. IP tests are done at room temperature, so hot water exposure is not covered. Users should avoid exposing phones to hot tubs, showers, or boiling water. We'll explain why hot water is risky and how it can compromise water resistance. Pressure changes, such as diving or rapid altitude shifts, can stress seals and membranes. Phones are tested at specific depths, but deeper water or sudden changes can cause leaks. We'll explore how pressure affects water resistance and why users should avoid deep water or rapid changes with their devices. Physical impacts like drops or bumps can crack seals, dislodge gaskets, or damage membranes. Even a minor drop can compromise water resistance, making leaks more likely. Manufacturers warn that water resistance is not guaranteed after physical damage. We'll discuss how drops affect protection and why careful handling is essential. Over time, seals, gaskets, and adhesives can degrade due to heat cycles, UV exposure, and repeated use. Aging materials lose flexibility and effectiveness, increasing leak risk. Water resistance is strongest when a phone is new, but weakens as it ages. We'll examine how aging affects protection and why regular maintenance is important. Opening a phone for repairs can compromise water resistance. Even skilled technicians may not restore original seals, and replacement parts may lack proper gaskets or adhesives. After service, water resistance is often reduced or lost entirely. We'll discuss why repairs affect protection and what users should know before servicing their devices. Phones experience heat cycles from charging, usage, and environmental changes. These cycles cause materials to expand and contract, stressing seals and adhesives. Over time, Repeated heat cycles can weaken protection and increase leak risk. We'll explore how heat affects water resistance and why it's a hidden factor in everyday wear. Brands avoid calling phones waterproof because no device can survive all water exposure indefinitely. Water resistance is limited by depth, time, and real-world conditions. Calling a phone waterproof would be misleading and legally risky. We'll explain why manufacturers use water-resistant and what it means for consumers. Apple uses a combination of precision seals, adhesives, and nanocoatings to achieve high water resistance. Their devices are rigorously tested for IP67 or IP68 ratings, but Apple warns against intentional water exposure. Repairs must be done by authorized technicians to maintain protection. We'll look at Apple's engineering philosophy and how it balances aesthetics with durability. Samsung combines innovative materials, flexible gaskets, and advanced adhesives to achieve water resistance. Their devices often feature IP68 ratings and are designed for everyday use, but Samsung also cautions against salt water and pool exposure. We'll explore Samsung's approach and how it adapts to different models and user needs. Rugged smartphone makers go beyond mainstream brands, using thick rubber gaskets, port covers, and reinforced membranes. Devices are often rated for higher IP levels and tested against drops, dust, and water. These phones sacrifice some aesthetics for extreme durability, making them ideal for harsh environments. We'll compare rugged phones to mainstream models and see what makes them unique. Apple and Samsung both use advanced engineering, but their approaches differ. Apple focuses on precision and aesthetics, while Samsung emphasizes flexibility and innovation. Both brands achieve high IP ratings, but their devices respond differently to repairs, aging, and real-world exposure. We'll compare their strategies and what it means for users. Rugged phones offer extreme protection but are bulkier and less stylish. Mainstream devices balance water resistance with slim designs and usability. Users must choose between durability and aesthetics, depending on their needs. We'll discuss the trade-offs and help viewers decide which approach suits their lifestyle. Brands often market water resistance as a major selling point, but real-world performance depends on engineering, usage, and maintenance. Marketing claims can be misleading, and users must understand the limits of their devices. We'll expose the gap between marketing hype and scientific reality, helping viewers make informed decisions. The real magic of water resistance happens behind the scenes. Engineers use advanced modeling, precision manufacturing, and rigorous testing to ensure protection. Every component is carefully designed, from the tiniest gasket to the largest adhesive layer. We'll reveal the hidden engineering that makes water-resistant smartphones possible. Users play a crucial role in maintaining water resistance. Avoiding salt water, hot water, and physical damage helps preserve seals and coatings. Regular cleaning and careful handling extend protection. We'll share practical tips for maximizing water resistance and keeping devices safe in everyday life. The next frontier in water resistance is fully portless phones. By eliminating USB ports, SIM trays, and physical buttons, engineers can create devices with fewer entry points for water. Wireless charging, eSIMs, and touch controls are paving the way. We'll explore how portless phones could revolutionize water resistance and what challenges remain. Self-healing seals are an emerging technology that could repair minor damage automatically. Using special materials, these seals close small cracks or gaps when exposed to moisture or heat. This innovation could extend water resistance and reduce maintenance needs. We'll look at how self-healing seals work and their potential impact on future devices. Hydrophobic nanotechnology uses advanced coatings to repel water at the molecular level. These coatings can protect internal and external components, reducing corrosion and short circuits. As research advances, hydrophobic nanotech may become standard in future smartphones. We'll explain how this technology works and its promise for water resistance. Future smartphones may enable underwater communication, using specialized membranes, antennas, and waterproof electronics. These devices could be used for diving, rescue, or marine research. Engineers are developing new solutions for reliable underwater connectivity. We'll explore the possibilities and challenges of underwater communication technology. The future of water resistance includes advanced waterproof electronics, components designed to function even when wet. Engineers are developing new materials, coatings, and circuit designs that can survive immersion and continue working. We'll look at how these innovations could change the way we use smartphones in wet environments. Authentic water resistance relies on rigorous testing standards. Industry labs follow strict protocols, using calibrated equipment and certified procedures. Brands must meet these standards to claim IP ratings, ensuring scientific accuracy and consumer trust. We'll explain how testing standards work and why authenticity matters for water resistance claims. Many myths surround water resistance, like believing all IP68 phones are safe for swimming or that water damage is always covered by warranty. In reality, warranties often exclude water damage, and IP ratings don't guarantee survival in all conditions. We'll debunk common misconceptions and clarify what users should really expect. Water resistance is a blend of engineering excellence and marketing strategy. Brands must balance scientific accuracy with compelling claims, ensuring users understand both the benefits and limitations. We'll present a balanced perspective, highlighting the importance of informed choices and realistic expectations. Let's recap the key points. Water resistance is achieved through seals, adhesives, gaskets, and coatings, but it's not permanent or absolute. IP ratings provide guidance, but real-world conditions can exceed lab tests. Brands like Apple, Samsung, and rugged makers use different approaches, each with trade-offs. Future technologies promise even greater protection, but users must stay informed and cautious. Understanding the science and limits of water resistance is essential for every smartphone owner. As technology evolves, water resistance will become even more sophisticated. Portless designs, self-healing seals, and advanced nanotechnology are just the beginning. The dream of truly waterproof electronics is closer than ever, but users must remain vigilant and realistic. By understanding the hidden engineering and marketing realities, we can make smarter choices and embrace the future of mobile technology. Thank you for joining us on this cinematic journey into the reality of water resistance in smartphones. Stay curious, stay informed, and remember, the best protection comes from understanding both the science and the limits. With knowledge, you can enjoy your device confidently and look forward to the innovations yet to come.